So the last thing that we're going to review is how to solve a system algebraically. On the first page, we are going to start by doing a review of solving by graphing. I'm going to call on a few of us. I would like to start by graphing these two lines. If we start with the first one, y equals -2 add x. Berkeley, how would I graph this line right here? This y equals -2 add x. Great, love that. Notice that she didn't just take the last number. -2 is our y-intercept. Okay, Berkeley, what is our slope? Yeah, 1/1. So we go up 1 to the right 1, down 1 to the left 1. Okay, so do that, please. Hopefully your graph is a little more accurate than mine. And then I want to graph this second one. AJ, how would you like to go about graphing the second one?
2x equals 6 and divide by 2.
Okay, so you're finding the intercepts?
Yeah.
It sounds like? Okay, so you put in a 0 for y, so you get 2x equals 6 and x equals 3?
Yeah.
So then what is the point?
The point is 3 on the x-axis.
Okay, so 3, 0. Thank you. Okay, and then what?
And then find the y, so it's plug in 0 for x, then it's negative y equals 6 divided by -1 on each side, then it'll be y equals -6. Negative 0, -6.
Okay. 2, 3, 4. Thank you, AJ. It's not the only way. If you wanted to solve for y, that works too. My lines are not very accurate because on this program I can't draw a straight line. It looks like this is the point of intersection. Can you all tell me if it's the same on yours? Yeah. Kai, what are the coordinates of that point? 4, 2. Okay, because I am so unsure, I want to verify my solution before doing anything else, so we're going to skip B and just go on to part C, verifying the solution. Charlie, how would I verify that solution of 4, 2?
You substitute x for 4 and y for 2.
Into where?
Either of the equations.
Okay, which one would you like to use?
The top one.
Top one. Okay, so can you tell me what I should write?
2 equals -2 plus 4.
Okay, so I get 2 equals 2. Janet, is that enough to say, yes, the solution works? Terrell, would you like to add on?
No, because that means that only the top one is right, not the second one.
Okay, great. Love that. So we've shown so far that this point is in fact on the first line. We have not shown that it's on the second line. Kaylin, can you tell me what it would look like to substitute that point into the second line? I want to substitute my solution into this second line. Can you tell me how to do that?
We would multiply 2 by 4 and y by 2.
Okay. So I have 8 minus 2 equals 6. 6 equals 6. So yes, we have in fact found the correct solution. None of that should be new. We okay with that? Okay. I believe what all of us learned last year is how to solve using substitution. Substitution is the idea where you find one variable by itself and plug into the other equation. So what we notice is our top equation, we already have y solved for. So what we can do then is in our second equation, we replace y with this -2 plus x. So we're going to substitute that into the bottom equation. So the bottom equation right now is 2x minus y equals 6. But we know that y is negative 2 plus x. So what I'm doing is replacing this y with negative 2 plus x. And then we still have equals 6. There is an issue right now, and I've seen an issue like this before. What is the issue? Okay, we absolutely have to have parentheses. There have to be parentheses there. Thomas, why do those parentheses matter?
Because if they aren't there, it would be plus.
I don't know if I fully understand.
I guess, would it just be like 2x plus 2 if they weren't there, or?
Not quite. Zulkarnain, why do the parentheses matter?
They need to be done first, so
So what would we have to do?
use parentheses use parentheses.
Okay. Terrell, what did you say?
Distribute.
Distribute. That's why we need these parentheses, to tell us to distribute. So we get 2x, add 2, subtract x equals 6. We're going to combine like terms. So 2x subtract x is x. Then subtract 2. So we get x equals 4. We are not done. We still need to find y. What do we have to do to find y?
You have to plug 4 back into one of the equations.
Plug 4 back into one of the equations. Which equation would you like to use?
First one.
Yeah, let's use the first one. Let's pick the easier one. So we get y equals negative 2, add x, which is 2. So our solution is 4, 2. Okay, is this familiar to us? Okay, you all tell me, would we like to do another substitution problem together, or do we think that one problem was enough? One problem was good? Okay, I'm going to do one more or get us started on one more because I see a few of us who would like that. We're going to go to the next page though. So let's leave this page, go to the next one. Okay, I would like to do, let's do problem 6. Okay, problem 6. This one is different from the other system that we did because we don't have x equals or y equals. So we are going to need to start by getting a variable alone. Alyssa, which variable would you like to get alone?
Maybe y for the first problem.
Okay, I think we have two good options. Y is a good option, x is a good option because they have a coefficient of 1. They're going to be pretty easy to solve for. But Alyssa has said we're going to solve for y. So Alyssa, what do you want to do on that top equation?
Minus 6x.
Subtract 6x. So we get y equals 4, subtract 6x. So now in our bottom equation, in place of y, we're going to put this 4 minus 6x. Chloe, can you tell me what that would look like in the bottom equation?
Parentheses 4 minus 6x minus 4y.
So start with the beginning of the equation. We should have x subtract.
X minus 4 and then in parentheses 4 minus 6x minus, or equals 18.
Great, thank you so much. So this is from our y. Okay, so now I'm going to keep going. Manny, what do I do from here?
Distribute -4.
Okay, love that. Change this to adding a negative. So we are distributing a negative 4. So that gives us x, add negative 16, add 24x is equal to 19. Okay. Avery, what do you think from here?
Plus 16 well, add like terms and then plus 16.
Okay, so we can do them both at once. So we get 25x, and then Avery also said add 16. So I think that gives us 35. So we're going to divide by 25. So our x is 35 over 25. That's okay. It's okay if we get a fraction. Does that fraction simplify? Yes. Maddie, how can I simplify that?
Divide by 5.
Divide by 5. So we get 7 over 5 for x. Okay, and then what would we do from here?
Plug it back into the first equation.
Yeah, plug it back into one of the equations. So maybe the first one. Could I use the second one if I wanted to? Yeah, a little more work, but... Okay, so we would get 4, subtract 6, times 7 over 5. Just use your calculator. Yeah, your calculator will do that for you. I will tell you, I believe we get negative 22 over 5. So our answer then, x comma y is 7 over 5 and negative 22 over 5. I want to write down 1 or 2 more things, and then I'm going to give you some time to work. What I want to make sure that we understand is that this is the only pair of x, y that makes both equations true at the same time. Also, this is the only point that's on both lines. And then 2 more things to write down. There are some special cases I want to remind us of. When we were graphing, one of the special cases was no solution. What did that look like when we were graphing and there was no solution? Parallel lines, thank you. There was also the case where we got the same line, where we graphed one line and then the other line ended up being exactly the same. What was that? Infinitely many solutions. Okay, what I want to review then is if we're not looking at a graph and we're solving using substitution or eventually elimination, what is that going to look like? How are we going to know if we get no solution versus infinitely many? Do you remember or have a guess? Caleb?
For like no solution, would it be like 2 numbers that don't equal each other?
Exactly. No solution. You're going to get a false statement. Like Caleb just said, 2 numbers that don't equal each other. 2 equals negative 3. If all of your x's, all your y's are gone and you get a false statement, that means no solution. What then about infinitely many solutions?
You get a true statement like 2 equals 2.
Exactly. Thank you. We get a true statement. Like 2 equals 2. Okay, questions for me? So back to page 1, we're going to do question 2. Let's talk about some graphing. Kaylin, how would I graph that first line? So this line right here. Which way do I go from the origin with that negative 2?
Oh, on the line.
But up, down, left, or right?
Down.
Down. Okay, so I'm going to go down 2. Zulkarnain, what am I going to do next?
You're gonna solve the next one, so
I'm still graphing the first one. So far, Kaylin has given us the y-intercept of negative 2.
you use the slope, which is up one, over one.
Okay, so I'm going to go up 1. Do I go left 1 or right 1?
Left.
Why left?
It's negative x.
Negative slope, right? So our line should be falling. Okay. I'm going to tell you right now that I've already seen the answer, and it's not a friendly answer, so you really have to graph this one accurately. Okay, Maddie, how would I go about graphing the second line?
Add 2x.
Add 2x. Okay, and so what would our equation look like?
Y equals 2x minus 4.
Y equals 2x minus 4. Okay. Ben, what would I do to graph that y equals 2x minus 4?
You start at -2, and then go down 1 and divide 1.
We're graphing the one in red, 2x minus 4.
Start at -4,
Okay.
and then go up 2, and then divide 1.
We get something like this.
Yeah.
Okay, do you see now why I said it wasn't very friendly? So, what we're going to do is we are just going to go right to problem 2. So we're going to, or problem 2b. So we're actually going to solve this algebraically so we can figure out what that point actually is. In order to solve by elimination, you need x and y on the same side of the equation. So what I'm going to do is I'm going to take this first equation and I'm going to add x so that x and y are on the same side of the equation. So when I do, I get x add y is equal to -2. And then I still have my other equation of -2x add y is equal to -4. I should have said this earlier. I'm sorry I didn't. If you have an AirPod in, can you just take it out for right now? And then you are welcome to listen to music when we start working again. Okay, so the idea here with elimination is you either want the numbers in front of x to be the same or the numbers in front of y to be the same, but opposing signs. So we would need +2, -2. +5, -5, something like that. What we should notice is that y is pretty close. We have a 1y and we have a 1y. We just need them to be opposing signs. So what I'm going to do is if I take this top equation and I multiply it by -1, that will give me -x subtract y equals +2. Second equation, I just keep the same. So that is my -2x add y is equal to -4. The whole reason I've done that is now when I add these together, the hope is that I eliminate one of the variables, that one of the variables will drop out. So if I add down -x and -2x gives me -3x. -y and +y is just 0y, and then I get -2. So if I've done it correctly, a variable should disappear or should drop out, which it did. So I have -3x is equal to -2. Divide by -3, divide by -3, and we get x equals -2 over -3. Does that simplify? Simplifies a little bit. Negative divided by a negative is a positive. So this is positive 2/3. Remember, that is about 0.67. Does that look like it makes sense with our point on the graph? Does it look like x is a little bit between 0 and 1? Yeah, definitely. Now we find y the same way. Go back and use one of your equations. I'm going to use the top equation. So our top equation is x add y is equal to -2. So our x is 2/3. So we have 2/3 add y is equal to -2. I'm going to subtract 2/3, subtract 2/3. So -2, subtract 2/3. I think we can do this without a calculator, so we're going to review that. Abby, how would I go about taking -2 and subtracting 2/3? What do we have to have in order to add or subtract fractions?
You would have to like multiply like both sides by like 3/2.
Close. So if I have this as -2/1, Archer, what do we need?
A common denominator.
Common denominator. So what am I going to do to that -2? Okay, so if I need a denominator of 3, I'm going to multiply by 3. So that will give me -6/3, subtract 2/3, which is -8/3. So my solution is 2/3, -8/3. Again, we got to ask ourselves, does that look like it makes sense with our graph? And it definitely does. Okay, I would like to know what this solution actually means. So we're not going to verify it. I'm going to tell you it's the correct solution. But what does it mean? There's two things I want to hear. What do you guys think? Maddie came up with one meaning. Maddie, what did you say?
Oh, it's where they intersect the lines.
This is the point where the two lines intersect. In other words, it's the only point that is on both lines. That's meaning number one. That's the meaning of the graph part. What is the meaning of just the equation part? Well, Zulkarnain?
They're the only pair of x and y coordinates that make both equations true at the same time.
Exactly. Thank you. This is the only pair of x and y that make both equations true. At the same time. Okay, we are going to do one more together, and then I'm going to have us work a little bit more. Okay, if you could go to the third page, which starts at problem 7. Starts at problem 7. I already see a mistake. On this problem 10, this should be 11. Y. Can you throw a Y in there? Problem 10 should be 11y. While we're at it, let's just do that problem. Okay, so when you start these problems that you're solving by elimination, you look at your x's, you look at your y's, and we need those numbers to be the same but opposite signs. So here's what I'm asking myself. Is there any number I can multiply 2 by to get 3? Any number I can multiply 3 by to get 2?
No.
Okay. What about on the y's? Can I multiply 5 by anything to get 11?
No.
Or 11 to get 5?
No.
No, nothing easily. So we're going to have to multiply both equations by something. Because x is the smaller number, I'm going to try to get rid of those x's. Jacob, what do you think I should multiply the top equation by? 3. Okay, so if he multiplies that top equation by 3, we're going to get a negative 6x, subtract 15y equals, don't forget that 9. So that's going to equal 27. So if he opted to get a negative 6x, we also are going to need a positive 6x. That will get rid of our x's then. Kai, knowing that we need a positive 6x in that second equation, what should we multiply the second equation by?
3.
So right now we have a 3x. We need to turn it into a 6x. 2, exactly. Yeah, exactly. We're going to multiply everything by 2 to give us that positive 6x. Okay, so then it'll give us a 22y and an 8. If we've done everything correctly, when we add these together, something should drop out. And so we notice we get a 0x, which is what we wanted. Negative 15 add 22 gives us 7y, and then equals to 35. So just 7y equals 35, so our y then is 5. Not done yet though, still have to find x. Marin, what can I do from here now that I have y to find x?
Forgetting
Okay, which equation would you like to use?
the bottom one.
Let's use the bottom one. Sounds great. Okay, so we get then 3x, add 11, our y is 5, equals 4. So 3x add 55 equals 4. If I subtract 55, we get 3x equals negative 51. Does anybody know off the top of their head what 51 divided by 3 is?
17.
It is. Wow, good. Very good. Negative 17. So we get then negative 17 comma 5. Okay. Questions for me? Okay. Okay, the last thing I want to do is problem 13. So in the last page, we're still solving algebraically. You can use any method you want though. So I'm just going to talk about the way that I think about this. When I look at question 13, maybe you have a preference. Maybe you like substitution better. Maybe you like elimination. In order to use substitution, we have to either get x equals or y equals. Is it going to be easy with either equation to get x by itself or y by itself? No. So I would say probably don't do that. Do elimination instead. That's the idea. If we look at question 15, for example, is it going to be easy to get x or y alone for substitution? We should be saying, yeah, we already have y equals. So for that one, we're already set up to do substitution. Does that make sense? Do you want me to go through a full problem? No. Okay. Whatever you don't finish is homework. You've got 10 minutes to work now, and then we have one thing to do before you go. So keep working. If you have questions, let me know.